Hello, student. I hope that you are doing well. Welcome to Dr. Kim's 2025 channel. I am Hamid Reza Motifer. Today, I want to talk about how to write chemical formula in chemistry. This is a part two. As you remember before, we talk about in the part one binary ionic compound in the part one. If you have any question about the part one, please let me know. And today I want to talk about the part two. First of all, this is a Dr. Chemist 2025 channel. Please subscribe this channel to support me to create more video for you. And please hit the bell. When you are hitting the bell, you do not miss any new video that I put in this channel. Thank you very much. And today I want to talk about type 2 formula. Type 2 formula, it's a polyatomic ionic compound. What was the type 1? Type 1 was the binary ionic compounds. You remember that? If you have any question about the binary ionic compound, go to the first video. This is part one for this chapter actually. And please look at this video. And you remember that the binary ionic compound consists of two elements. One of them is metal, one of them is non-metal. Metal loses the electron, create a cation, and the non-metal gain the electron to create an anion. Between the anion and cation there is an ionic bond. That's why we call them ionic compounds. And remember that how to recognize them. How to recognize them. Do you remember that? Aha, that's right. They are ending with the IDE or ide. For example, sulfide with the ID S2 minus, or chloride IDE Cl minus. If you have any question, go to the part one and watch that video that I put in this channel. But today I want to talk about the type 2 formula, polyatomic ionic compounds. Okay, first of all, I want to answer this question. What is polyatomic compound? What is polyatomic ionic compound? To answer this question, I can say, let me change the color. A compound containing at least one polyatomic ion. Okay, at least one polyatomic ion. Most of them, the polyatomic ion has negative charge. And in this way you can see the cation plus polyatomic ion to create polyatomic ionic compounds. Okay, let's get to start with this polyatomic. What is the polyatomic and how we can recognize them? So, how to recognize poly or polyatomic sorry ionic compounds? It's so simple. They are getting end with ATE or IT. AT8, IT8, ATE8, sorry, ATE8 or ITE8. You remember that the binary ionic compound get end with the IDE8, so they are getting end with the 8 or 8. And remember that hydroxide is getting with the IDE as a OH minus, or cyanide as the Cl minus. They are belong to polyatomic ionic compound. They are getting end with the IDE, and you remember that the IDE belongs to the binary ionic compound, but hydroxide and cyanide was the exception. They are getting end with the IDE, but they are belong to the polyatomic ionic compound. Okay, let's go to the next page. And we want to know about the polyatomic ions. What are the common ions? So, the common polyatomic ions. Okay, let me change the color. First of all, oh, where's my pen? I couldn't find my pen. Okay, it's here. First of all, ammonium. Ammonium is a NH4 plus. This is the only polyatomic ions with the positive charge. All of them have negative charge. For example, carbonate, look, ATE, CO3, 2 minus. And bicarbonate or hydrocarbonate, it should be H, CO3, 1 minus. You remember that the H is positive, so if you add the 1H here, so it's a positive, so The minus 2 minus is getting the 1 minus. That's why it's a 2 minus and this is a 1 minus. And hydroxide OH, that was an exception with the IDE, but this is belong to this one. Carbonate, bicarbonate, look. If you look at them, it's a 8, it's a 8, and this one is Ide. Ide was the exception. Okay, keep going. Night. Oh, let's see. Yeah. Night, right, and night, right. You remember that the night, right. Nitrite was the binary ionic compound, and there is only one atom inside, N3 minus. You remember that. If you look at the part 1, you can find it. Nitrite. Here is a nitrate and a nitrite. Nitrite should be NO2 minus. Nitrate should be NO3 minus. Remember that 8 has one more oxygen than Ide. Nitrate NO3 minus 1, nitrite NO2 minus 1. Okay, let's keep going. And sulfide and sulfate. You remember that. Sulfide with the IDE was S2 minus, binary ionic compound. But here I have sulfate and sulfide. Sulfide SO3 2 minus, and sulfate one more oxygen, you have to add 2 SO3. It should be SO4 2 minus. You remember that. SO4 2 minus. And the chloride, chloride, you remember that the chloride IDE was Cl minus, but the chloride should be ClO3 minus. Oh my God, what's happening like that? I'm sorry. Sorry about that. Oh, yeah, it's here. And chlorate should be ClO3 minus. And I wrote here. For example, phosphate, and you have a phosphide. Phosphide was P3 minus, but the phosphate should be PO4 3 minus. Okay, in this page, you learned a lot of common polyatomic ion that use into writing chemical formula. Let me bring more example. First of all, I want to say something about the multivalent metal. Have you ever heard about the multivalent? Yeah, multivalent metals. Multivalence metal is a kind of the metal with two or one more actually, one more valency. For example, copper, it should be positive 1 or positive 2. For example, iron, it should be positive 2 or positive 3. For example, lead, plumbat or plumbus, positive 2 or positive 4. Tin, positive 2 or positive 4. Or gold, positive 1 or positive 3. Or mercury, positive 1 or positive 2. There is a one note about the mercury. It's belong to the AP chemistry. I will talk about it more in the future because this channel it's belong to the AP and SAT test too. Okay, multivalent metal. How we can show them the valency? For example, we have to show them with the Roman numeral. For example, copper 1. Copper 1. In the parentheses, you have to write copper 1 or copper 2. You know the Roman numeral. Roman numeral. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. 8. That's me. 8, 9, 10, 11, 12, and more. So, for example, I want to show lead 4. It should be lead 4. So it should be Pb 4 plus. And you remember that they are metals with a positive charge. And when we are talking about them in the chemical formula, we have to show them the valence in the parentheses. Do not forget about that. Okay, let's bring more example about them. Go to the next page. For example, I want to write the formula of the sodium carbonate. Sodium is a Na with the valency plus 1. Carbonate should be CO3 with the 2 minus negative charge. And we have to create the neutral compound. So if you wrote NaCO3, it should be positive and 2 minus, so it can create a minus 1. Is not a neutral, so it's not correct. You have to create a neutral compound. So you have to bring 2 sodium and 1 CO3 2 minus. Look, in this situation, it's a 0 and this is neutral. So it can create Na2CO3. This is the meaning of what's happening inside, but I want to give you a fast way. Because when you want to write, let me change the color. For example, when you want to write sodium carbonate, you have to write sodium carbonate. What is the charge for the sodium? Is 1 gives the CO3, and CO3 is a 2 gives to the sodium. So it can create Na2CO3. It is a very fast way if you want to compare with this way. But this way, it's a kind of the meaning. So from now, I want to use the fast way because you don't have time to do it in your test or something like that. But you have to know what's happening. You have to know what's happening. Okay, for example, you want to write magnesium nitrate. You know that the magnesium is Mg. If you look at the periodic table, it's in the group 2, so it should be 2 positive charge. Nitrate, you remember that the nitrate was here. Look, nitrate, NO3. You have to memorize them. Write it down. I think write in the paper attached to wall and look at it every day to remember that. And here, magnesium nitrate. Nitrate should be NO3 minus 1. Okay. So the charge of the magnesium is 2, gives to the NO3, and then NO3 gives 1 to the nitrate. So it can create MgNO3. NO3 should be 2 times. So when there is more than one atom or element, you have to put in the parentheses MgNO3 2 times. MgNO3 2. Magnesium nitrate. Another example. You have to write the calcium, for example, sulfide. Calcium sulfide should be calcium Ca2 plus, and the sulfide should be SO3 2 minus. The calcium gives the 2 to the CO3, and the CO3 gives to the 2 to the calcium. So multiply, simplify them, so it can create CaSO3. No need to put the parentheses. No need to write the number 1. CaSO3. Another example. For example, you want to write iron 3 sulfate. Look, sulfide, sulfate. Sulfate has one more oxygen than SO3, so it should be SO4. Iron should be Fe with the 3 positive charge. Sulfate should be SO4 2 minus, and it can create FeSO4. Fe gives 2, it gives 3 to the SO4, and SO4 gives 3 to the, SO4 gives 2 to the Fe. And here Fe2 SO4 3 times. How about the meaning of this one? The meaning of this one, if you put the iron 3 and SO4 2 minus, it can create a positive one, is not a neutral. If you want to get a neutral, you have to bring 2 iron and 3 SO4. Two iron can create positive 6, and 3 SO4 can create minus 6, so it's a neutral. That's why we need 2 iron and 3 SO4. That's why that we need 2 iron and 3 SO4. 2 iron and 3 SO4. You got it? Okay. And more question. For example, ammonium ammonium hydroxide. Ammonium, the only polyatomic ion with a positive charge, NH4 plus. Hydroxide, OH minus. It gives 1 to the NH4, and NH4 gives 1 to the OH. So it can create NH4 OH. You got it? And one more question. You want to write the copper 2 multivalent metal, copper 2. Copper 2 colorate 8. Copper should be Cu with the 2 positive charge. Colorate should be ClO3 minus. You remember that? Go to this page. Where is the colorate? Colorate should be here. Look, colorate, ClO3. Okay, ClO3, and the copper gives 2 to the ClO3, and ClO3 gives 1 to the copper. It can create Cu1. You do not need to write 1 and the ClO3 in the parentheses 2. I think that I bring a lot of example for you. I hope that you enjoy this part and have a good time. If you have any question, please let me know. Have a good time. Do not forget to subscribe this channel to support this channel. Thank you very much and have a good time.